let us now see some problems relating to the derivatives for vector functions. So let us see this first question. The question here is, the vector point function f of t is constant if and only if its derivative is equal to 0. So we have to show this thing. So prove that. In order to prove this thing, firstly we'll assume that f of t is constant, and then we will prove its derivative is equal to 0, and conversely, because we are given this if and only part, right? If and only if part. So we have to prove the converse also. In that case, we'll assume this particular thing and we'll prove this that the function is a constant function. So for this, firstly we are assuming the function to be constant function. So suppose the function is k. So using the definition for the derivative, the value of this term and this term would be going to be k only, because it is independent of t, so it is going to be 0. So this proves our first part. For the second part, where we have assumed the derivative to be equal to 0, we now have to show that this is a constant function. This is a constant vector, the vector f. So for that, let us assume our vector to be f1t I cap plus f2t j cap plus f3t k cap. Now, first of all, let me tell you about this I cap, j cap and k cap. What are these? These are the unit vectors. I cap is a unit vector in the direction of x-axis, right? In the direction of x. This is a unit vector in the direction of y, and this is a unit vector in the direction of z. So that means it represents how much the vector f is represented in this x direction. This gives you how much the vector is defined in this y direction and how much the vector is defined in this z direction. So we assume our function, the vector f vector t, that is equal to f1t I cap, f2t j cap and f3t k cap. So in this case, if you take the derivative for this particular vector, so it comes out to be the derivative for this function f1t I cap as such, then the derivative for this f2t, so j cap as such, and then the derivative for this f3t, that is and k cap as such, right? So this is your derivative. Now in the question you are given this is equal to 0. If this is equal to 0, that means this right hand side is going to be 0. Now when can you say a vector to be 0? When all the components, what is 0 vector? 0 vector is 0 I cap plus 0 j cap plus 0 k cap. So in this case you can equate the coefficients for I cap, j cap and k cap. So you can say this derivative term is equal to 0, this derivative term is also equal to 0, and this term is also equal to 0. And what are these? f1t, f2t, f3t? They are some functions of t. So if the derivatives are equal to 0 and these are scalar quantities f1, f2, f3, so we can conclude from here that these are f1, f2, f3, they are constant functions. So that means they do not depend upon the variable t. They are constant. Now if they are constant, what were they? They were the components of this vector f, right? So if they are constant, so obviously your vector is also going to be constant. So this is what we wanted to prove in this particular question. Moving on to next question. Here they are saying if f of t has constant magnitude, in that case we have to prove that the vector f dot with its derivative with respect to t going to be 0. For that we are assuming the function to be of constant magnitude. So that means the modulus of this vector f is equal to constant, right? And we have to see what happens to this particular quantity. For that, what we are doing, we are taking the dot product of that vector by itself. So if you see by the definition for this dot product, this vector f dot product with vector f is going to be the magnitude of vector f with the magnitude of vector f with the cos of angle between f and f. Now they are same vector, so the angle between them is going to be 0. So we have cos of 0, and what is cos 0? It is equal to 1. So you have the magnitude of vector f whole square. So this is what I have written over here. and because this is given to be constant, so its square is also going to be constant. Now if this is constant, so when I take its derivative, this would be going to 0. If this is going to be 0, you can open up the definition for this derivative using the properties of derivative. So accordingly you have this expression, so this is going to be 0. Now this quantity here and this quantity here are the same. Why? Because a vector dot b vector is equal to b vector dot a vector. So according to this, using this, you can write this to be 2 times vector f dot product with its derivative. So this is equal to 0, or in other words, you can write the vector f dot the derivative for this vector as equal to 0, right? So this is what you wanted to prove. In the third question, they are saying if you take the vector to be of constant direction, in that case its cross product with its derivative is going to be a 0 vector. Now why this is a 0 vector? Because you know the cross product of two vectors is again a vector, so this is going to be 0 vector and not just a single numbered 0. So in this case we have to assume the vector. Suppose the vector is f, vector f, right, with an arrow. So we can write this to be f and f cap. Now this f cap represents the unit vector giving you the direction of vector f, and this gives you the magnitude of the vector f. So in this question they have told you that this vector has constant direction. So that means this f cap is going to be constant here. So this means f cap is going to be constant according to given condition. If this is a constant quantity, so we can now define, because we are interested to look at this particular term. So for that we look at what is the derivative for this vector. So when you take the derivative of vector, you will substitute the value for this vector f to be f into f cap. Now you have two terms and you wanted to take its derivative. So using the properties for derivative, you can write this to be like this. And now because this quantity is defined to be constant, this is given to you in the question, so its derivative is going to be 0, so you are left with just this quantity. So this is the derivative of the vector f. Now we wanted to do the cross product of the vector f with the derivative that we have just calculated to be equal to this particular term. So when you do when you take the value for this vector f was your this quantity, right? So we just substituted it over here. So this is your vector f, and what is this term? The derivative for this vector f, that comes out to be this quantity df by dt f vector, right? So this is equal to this particular quantity. Now here when you take the cross product, you take the cross product according to this direction. So you can now, because this is magnitude and this is also magnitude, they could be taken outside. So this is what I have written, and then you are left with f vector crossed with f vector. Now this quantity is equal to 0. Why? Because when you take the cross product of the same vector, you obtain 0. Because what is the definition here? If you look at this, f cap cross with f cap, that is equal to the magnitude of this f cap, the magnitude of this f cap into the sine of angle between them. Now because they are same, the angle between them is 0, right, into n cap. So because this is unit vector, its magnitude is 1, this is also unit vector, magnitude is 1, and sine of 0 is 0. So finally you have 0 here, right? So this is equal to 0. So this is what we intended to prove, that this quantity here is equal to 0, right? So these questions you can take them to be the properties, and you could also remember them. So they say if the vector has constant direction, then its cross product with its derivative is 0. When the vector has constant magnitude, then its dot product with its derivative is 0. This is also to be taken as the property. And the first question, that was that says that if the function is constant, it could only happen when the derivative is equal to 0 or conversely. So you could remember them as the properties. Okay, so let us now move on to the last question. It says that you are given the vector A to be this one, vector B to be this one, and vector C to be this, right? So you have to find out what is, firstly you will calculate what is B cross C, and then you will, whatever is this vector, you take the cross product of this vector with vector A, whatever is that vector, then you differentiate that vector with respect to theta, and finally you substitute the value of theta equal to 0. So let us proceed in a similar way. So you take this vector B and you perform the cross product with this vector C. So this is what we are doing. So how do you compute this cross product? You just take I cap, j cap and k cap, and then take the determinant of the coefficients of I here. So it is cos theta minus sin theta and minus 3. So cos theta minus sin theta and minus 3, and then for vector C we have 2 plus 3 and minus 3. So we have 2 plus 3 and minus 3. So when you take the determinant, it comes out to be I cap. So we are opening this determinant along this direction. So this is I cap. You multiply this term with this term minus this term with this term. So you have 3 sin theta plus 9. Then for the second term you have minus j cap. For minus j cap, you multiply this term with this term and then minus this term with this term. And for the third case, plus k cap, you are multiplying this term with this term minus this term with this term, right? So this is what I have listed over here. Okay, so once you have this vector B cross C, so this is our vector. Next we will take its cross product with that of vector A. And what is vector A? It is given to be sin theta cos theta, sin theta I cap, cos theta j cap plus theta k cap. So accordingly we have I cap, j cap, k cap, the values of for A vector, which are sin theta, cos theta and theta, and the values for B cross C, they are this 3 sin theta plus 9, so 3 sin theta plus 9, and then we have minus 3 cos theta plus 6, this one and this one. So now you just have to open up this determinant in a similar fashion. So once you open up this, you are left with this vector. Now the next task is to take the derivative for this particular vector with respect to theta. So you will take the derivative for all these individual terms. So you will be getting all these terms, right? So this, I think you would perform this one. So finally this is your derivative, and thereafter you could substitute the value of theta is equal to 0 here into this particular expression. So your cos theta would become cos of 0 is equal to 1, and your sine of 0, that is equal to 0. So this term here becomes equal to 5i cap plus 6j cap minus 6k cap, and this is the answer that we were seeking. So I hope these problems are pretty clear to you.